In this video, we'll see how to add animation or motion into our Pygame drawings. So the basic idea behind creating motion, or at least simulating motion, is that instead of using constants to draw our shapes at a specific location, we'll use variables to do so, right? Constant means the same always, variable means changing. So we'll have in our demo here, let's go back to the same demo we were using in the last video, let's use this rectangle. So instead of drawing this rectangle at the constant 100, 100, we'll draw it at some variables x and y. Now for movement we need to do this in a loop, so we're going to repeatedly draw the background, so that's screen.fill, then draw the foreground, in this case our rectangle, and then we'll move everything and start over. So we'll get a brand new location, and then we'll draw things again. So let's see this in our demo here. Let's create some variables x and y. Let's do that outside of the loop. So x equals, let's say 0, and y equals, we'll keep that at 100 for now. Okay, so now each time through the loop we're going to draw our rectangle at this location, so 0, 100, but then we're going to change the location that it's at. So the next step will be x plus equals 1. Okay, and then we flip and we start everything again. So let's see this go. We run our demo, and off it goes. And it's real quick, so I'm going to run it a second time. And here we go, one last time here. Whoosh, super fast. So that the rectangle started at the left-hand side here, and because x was changing each time through, it ran across the screen really quickly. Now, one thing to point out is without this screen.fill here, each iteration through this loop gets drawn on top of itself. So if I get rid of this line and run this again, this is going to be really quick, but pay attention. It starts off with nothing, and then that rectangle moves across the screen but doesn't get erased as it goes. So we get, there. It just moves across the screen and we get a line following where it went. Run this one more time. Whoosh. And it runs across the screen and fills everything in. So it's important to make sure that we're refreshing the screen every time through. We're replacing everything that was there, drawing this blue color across the background, and then drawing everything on top in its new location. Otherwise, we just get that blur of a rectangle smearing across the screen. Now, this example finishes kind of quickly. I'll run it one last time here. It's over kind of quick. So it would be nice if instead of just going off the screen and being gone forever, once it goes off the screen, it starts back at the beginning of the screen. So try and solve this for yourself. Pause the video, see if you can't figure out how to make the rectangle start back at the left-hand side of the screen after it's gone off the right-hand side of the screen. Okay, so now let's see if I can't solve it for you. So we have x increasing by 1 here. Actually, I'll do this after. So that's the thing that's making our rectangle move, right? It's going to be 1 pixel to the right each single time we draw this screen. So what's going to happen is if it gets so far that x is now off the screen, so if x is greater than our screen width variable, well then it's gone too far. So at that point we can say x equals 0. So if it gets too big, it's off the right-hand side, then we'll just set it back to the left. Close this and try again. And there you go. Now it's running forever. As soon as it goes off the right-hand side of the screen, it comes back. We could also have used modulus with this, x equals x plus 1 mod the width of the screen. So if it gets too big, if it's bigger than the screen width, it starts back down at 0 again. How about moving this with a bounce? So instead of starting back at the left-hand side when it reaches the right, it starts moving in the leftward direction. So it starts off at the left-hand side, comes across, hits the right-hand side, and then bounces back. Rather than teleporting back, it moves back to the left. So again, pause the video, try this for yourself. And now I'm going to demonstrate the solution. So, similar idea as before, but instead of always going up by 1, instead of always increasing by 1, we're going to have to sometimes increase by 1 and sometimes decrease by 1. So what we're going to do is use a variable here as well. dir stands for direction. So we'll say dir equals 1. So initially we're going to the right. That's already a variable name by the highlighting, so we'll call it xdir. There you go. So the x direction. X is now still going to be increasing by 1. So far we haven't changed anything. We've just put it into a variable. But what we'll do is if X reaches the right-hand side like it does here, rather than setting it to the left, we'll just change the direction. So instead of increasing by 1, we'll increase by -1. So X dir times equals -1. So if this was 1, 1 times -1 is -1. If this was -1, -1 times -1 gives us +1. So that's going to change direction. Now this condition here says we've reached the right-hand side of the screen, but if our square is going to be moving to the right and then back to the left and to the right again, we also have to include an option that it's at the left-hand side of the screen. So in addition to being x is greater than the screen width, we'd say or x is less than or equal to 0. That is the wrong language, isn't it? Yeah. Less than or equal to. So save and try this now. Bouncing back and forth. So x is going up by x direction when it's heading to the right, and at that point this becomes true, the screen width, and then it flips the x direction so it becomes -1, so it starts traveling to the left. At that point x becomes so small that it's 0, so it flips the direction again and it starts increasing by 1. Now, if you look very closely, or possibly if you slow down this video, you might notice that when this rectangle reaches the right-hand side, it's actually the top left corner. See if I can catch it. There we go. It's actually the top left-hand corner of the rectangle that's hitting that left-hand side before it bounces. That's because the X location is actually marking the top left corner of the rectangle, the left side of the rectangle. So if we want to fix that so it's bouncing without going through the wall and then coming back, we can change this condition a little bit. And instead of saying if x is greater than the screen width, we can say if x is greater than the screen width minus the size of our rectangle. So minus, we'll call it width. Now that's actually a variable here, so we can say minus 50 in this case. We're going to change all this in a second, but there you go. Close this, save this, rerun it. There you go. Now it's harder to see again still because it's running kind of quickly, but if I can catch it, close enough. You can see that it's bouncing off the side of the rectangle rather than going off the screen and then bouncing off the left side. All right. Now if we want to have our rectangle moving in 2 different dimensions, we can apply all the same information to this y variable as well. So let's create a y direction equals 1 and ask all the same questions. So y plus equals the y direction, and if y is greater than or equal to the screen height minus the height of our rectangle, which is 25, or x is less than or equal to, y is less than or equal to 0, then the y direction times equals -1. So instead of just bouncing back and forth, it now goes flying around the screen. Kind of like one of those old DVD pause menus, but on fast forward for some reason. All right, so our demo's gotten a little bit big at this point. Code's kind of all over the place. So it's going to need a little bit of organization. So let's rebuild this with objects, so we can see how objects play very nicely into this idea of simulation. So I'm going to make a new one here. I'm going to call this boxes.py. So we're going to have a bouncing rectangle in the end, but we're going to do everything with objects. So the idea is we're going to store the x, y direction and all the relevant information about that rectangle inside an object. Okay. We'll also store some random colors as well. And then the behaviors for that object, for that box, is going to just be the ability to step, so to move 1 step in the current direction, as well as the drawing behavior will be stored in the object as well. Okay, so new file here. Let's import everything we need. So we're going to need pygame. And as I mentioned, we're going to have some random colors, so import random as well. Okay. Next, we're going to want our screen constants. Screen width equals 800 and screen height equals 600. You can use different numbers if you prefer. I like those numbers, so I'm going to keep using them. Now let's create the class here, but I don't want to actually fill this in just yet. So we'll say class box, and we'll say pass for now. So this is a stub method, or a stub class. We'll fill it in later. I just need it to be there so it is a placeholder for now. Okay. Then down here we'll say def main and create our proper simulation loop. So here we start off by initializing our screen. So pygame.display.set mode. and pass in our height and width. So screen width, comma, screen height. Okay. And then we'll make a new box. We'll say box equals box. So lowercase box here is an object of class box, which is just going to be like our rectangle as we've seen it before. Okay. And then we need our simulation loop. So I'll say while running instead of while not running or while not done. We'll use a running flag here. We're going to need an actual flag for that. Running equals true. And while running, check for close events. So ev equals event.poll. Figure out if event.type is equal to a quit event. So pygame.quit. Yeah, and if that's true, then running equals false. There we go. Right. Now let's do all the drawing. So draw the background. So screen.fill, and let's just draw a black background for this one, 0, 0, 0. And then we'll tell our box to take one step forward, box.step, and then draw itself. So box.draw to the current screen. Okay, now we haven't created those behaviors yet, so that won't happen. It won't actually run, but we'll have to put those into the box class when we have them. So this is some information we need to fill in when we get to it. All right, and that's pretty much it for our entire simulation. So pygame.display.flip to flip the buffer so we can see it later. All right, so let's fill in this box class now. So we have class box. First things first, we need the initializer, so def __ init, and that takes in self, and that's it. So box itself didn't have any extra information, so we shouldn't have any here either. And let's just give some default initial values to all the different things that we need. So we're going to need a width and a height. We'll call these boxes or squares, so we'll just give them one size. So self.size equals, we'll say 50 pixels. That will be both width and height. Okay. We need an x and a y parameter, so self.x equals, and let's just make this a random point on the screen. So to get a random number, random.randint. And now to make this a random number on the size of the screen, or anywhere on the screen, we'll start between 0 and screen width. And then we don't want to have this starting halfway on the screen, half off the screen. This makes the top left corner be on the screen, that is. And let's make it over so that the entire box stays on the screen. So minus self.size. Okay, so don't be so far to the right that part of the screen is off, so take back 50 pixels from the right-hand side. Okay. Similarly for the y-axis, random.randint between 0 and screen height minus self.size. All right. Next we need x direction and y direction, so self.xdir equals 1 and self.ydir equals 1. So start going down and to the right. Let's also put a random color. So self.r is going to be a random number between 0 and 255. So random.randint 0, 255. And then we can do that for all three channels. So R, G, and B. And just change that to G and B. And then when we're done with all those, actually we don't need to make these attributes, we can just have those as variables. And when we're done with all those, let's put those into an attribute. So self.color equals RGB. Okay. So self.color points at this list of those three numbers. So anytime we need to draw it, we can just say self.color, and that is a list of already three values. All right. So that gives us our initializer. Now when they say box equals box, it passes a new object in here, gives it a width of 50, a random location, a starting direction, and a random color. So what's next is we need to be able to make this box move, and we've seen the logic behind that. Now we're just tucking that into this class structure. So def step will be our function or our method, and that takes in just a self. And again, that's because step doesn't have any parameters down here, so it shouldn't have any, or sorry, it doesn't have any arguments down there, so it shouldn't have any parameters up here. Okay, so this step is going to do pretty much what our previous step did before, just now inside an object. So self.x plus equals self.x direction. and self.y plus equals self.y direction. And then step also needs to take care that we don't fall off the screen, so if self.x is greater than or equal to screen width minus self.size, or self.x is less than or equal to 0. In that case, then we're just going to flip the direction. So self.xdir times equals -1. Okay. And similarly for y, if self.y is greater than or equal to screen height minus self.size, or self.y is less than or equal to 0, then we'll flip the y direction. Self.wider times equals -1. Okay. So that takes care of the stepping. We'll have to test all of this, but we've tested this basic logic before. The only key difference here is now we're using self dot in front of the variables that we had before, which is to say all these variables are stored as attributes inside some object. Now, the only behavior we haven't constructed yet is this box.draw. This takes in the drawing surface, which we've called screen. So let's do that as well. So this doesn't have to do much. It's just going to be a call to the Pygame method. Need our self parameter as well, self and screen. That's just going to take all the information from the object and pass that into pygame.draw. So pygame.draw.rect. So we pass in the screen. We need a color, so that's just self.color. We need an x and a y location, as well as a width and a height. So self.x, self.y, .y, self.size for the width, and self.size for the height. Okay, so the rectangle needs the screen, the color, and those 4 pieces of information to figure out the location and shape. And we're grabbing all of that information, the color, the x, the y, and the size, all from the attributes stored in the specific object itself. All right, I think that's everything, so let's test this out. This guy's still running around. Let's try running this. This is now boxes.py. All right, so we imported everything. We forgot to run main, so nothing actually popped up. So let's run main here. Event is not defined. Oh, it's pygame.event is not. Pygame.event.poll. There we go. So the only error, if you're following along very closely, was I was missing pygame dot there. And there it goes. We have our box bouncing around like a crazy person trying to escape the screen, it looks like. Okay, so this is the exact same demo as before, but notice now all the logic representing the object that's moving around is tucked into this box class, whereas the simulation loop now just says step and draw. It's real simple. So draw the background, draw the foreground, flip the scene. Okay? So this makes our simulation loop a lot cleaner, and as it turns out, this design makes it very easy to translate into entire lists of boxes. So for example, let's add some many boxes here. So boxes equals an empty list, and then let's just make 5, box x boxes. So for underscore in range 5, so we'll repeat 5 times and say boxes.append, and then let's make a new box. Okay. Now, instead of single box.step, we have to say a loop here. So for box in boxes, box.step, and for box in boxes, box.draw. So step them all, then draw them all. Technically, you could step 1 and then draw it, and step 1 then draw it. It's just slightly more correct to move everything at once and then draw everything at once to separate the changing from the display of these boxes. But just like that, we've changed it so that we can now have 5 boxes frantically bouncing around the screen. Hooray! So excited. Now these boxes are bouncing a little bit too fast. The reason being is this loop will pass through as fast as it possibly can. We're running this on a relatively powerful machine, so it's making it through this while loop really quickly. So it's moving, drawing, moving, drawing, moving, drawing, and we end up getting a frame rate that's very fast, or a very large frame rate. What we can do in Pygame, though, is set the upper bound on the frame rate, that is to say how many times in a given second Pygame is allowed to go through this entire loop. So to do that, we just need to use the pygame.time submodule here. Here it is. So up at the top, around the place where we opened up the screen, we're going to have to create a clock as well, which is pygame.time.clock. That just gives us the ability to time things or control the time of our simulator. And then inside our loop here, doesn't actually matter where, but I tend to prefer it at the end of our loop, we put in clock.tick and then let's say 100. So what this 100 means is per second, the number of times we're allowed to call this tick method can be no more than 100. So if we pass this loop 101 times in a second, it's going to pause it on the last time through and wait for the next second. So it's going to slow down the execution of our program so that we end up with slightly more reasonable speeds. So let's close this, save our code, and try it out. There you go. With 100, it's much, much slower. Let's try this at about double the speed. Close that and try it again. There we go. And we get a sort of smoothly moving set of boxes. All right. So that's the end of this video. We've now seen how to animate or add motion into our drawings or into our simulations, and now how to make it so that motion is controlled in terms of time. The next video, we'll take a look at handling user events so we can do all sorts of fun things in these games. Talk to you in the next video.